Bismillahirrahmanirrahim. How are you, students? Today we will study physics lecture number 20, unit number 4, work and energy. So today we will do numerical problems. This is numerical 1, first numerical. So a force acting on an object varies with distance, shown as shown in the diagram. Diagram is given in the book. Diagram is like this. Distance is taken along x-axis and force is along y-axis. So this is the diagram given in the book. This is 4 meter, this is 6 meter. This distance is 2 meter and this distance is 4 meter. Force here is constant and it is equal to 5 Newton. So calculate the work done. We have to calculate the work done by a force as the object is displaced from 0 to 6 meter. So object is displaced from this position to this position. Now this is rectangle because its length is 5 and its width is 4. So you will find the area of this rectangle, which is equal to A1. Area of rectangle is equal to length cross breadth. So area A1 of rectangle length is, we will label O, A, B, C, and D. Length is OA. So write OA plus multiplied by breadth OC. So you will use this formula, you will find the area of the rectangle. And the area of triangle is equal to A2 and is equal to base into perpendicular. Base into perpendicular. So base in this case is CD multiplied by VC. Use this formula, you will find the area. You will find the area. Now, what we have to calculate? We have to calculate work done. Work done. We have to calculate work done, question mark. So work done is represented by W and it is equal to the area, area of rectangle plus area of triangle. So work done is equal to A1 plus A2. You will get the work done. So this is the graph. The area under the graph with x-axis will give you the work done during this journey. So do it. Numerical 2. A 70 gram mace. Mass of man is equal to M is equal to 70 kilogram. A long flight of stairs in 4 seconds. Time of flight is 4 seconds. The vertical height of the stair is 4.5 meter. Calculate the power. So power is equal to work per unit time. In this case, work is equal to potential energy and it is equal to mgh divided by T. So use this formula, you can calculate the work done. Numerical 3. A body of mass 2 kg. Mass, you will write data. Mass is 2 kg. Is dropped from a rest position 5 meters above the ground. This is the diagram. Here is a ball. It is dropped from a height of 5 meters. Height of 5 meters. above the ground. What is its velocity at a height 3 meter? So it covers a distance of 2 meter. At this position, we have to calculate velocity. This height above the height at 3 meter. So h minus x is equal to 3 meter. So when 3 meter height is lifted up, so out of 5, calculate the height. So you have to calculate the height. Um, Velocity above the ground. So v is equal to 2gx. We will calculate the velocity from the height covered, the distance traveled. So use this equation, you can calculate the value. The value of g is 9.8 meter per second square. Now, a man pulls a trolley to a distance of 50 meter. So write the data. Distance is 50 meter. By applying a force of 100 Newton, which makes an angle of 30 degree. With the horizontal, calculate the work done by the man. Work is equal to FD cos theta. F is 50 multiplied by 100 and cos 30. You will get the answer. Numerical 5. A man whose mass is 70 kg. Mass is 70 kg. Walks up to the third floor of a building which is 12 meter. Height is 12 meter above the ground in a time of 20 seconds. Find the power in watts in horsepower. So power is equal to mgh divided by t. M is 70, g is 9.8, and height is 12 meter divided by time is 20 seconds. You will get the answer in watt. Then write the answer and divide by 746. You will get the answer in horsepower. 1 watt is 1 horsepower. 1 horsepower is equal to 746 watt. A ball of mass 100 kg. Data. Mass is 100 kg. Thrown vertically upward at a speed of this one. Speed is 25 meter per second. If no energy is lost, determine the height. This is you will solve it separately because there is no resistance. Calculate the height. When there is no resistance, when there is no resistance, potential energy, loss in potential energy is equal to gain in kinetic energy. So half mv square is equal to mgh. In cancel, h is equal to v square divided by 2g. 25 whole square divided by 2 multiply 9.8. You will get the answer here, 31.9 meter. If there is no resistance. When there is resistance, you will change the theorem. Determine the height h. Now look, if the ball only raises to 25 meter, height is changed 25 meter. Calculate the work done against air resistance. Also calculate the force of friction. For force of friction, the symbolic representation is small f. These two we have to calculate. Now, according to law of conservation of kinetic energy, according to the law of conservation of kinetic energy, conservation of energy, conservation of energy. Loss in kinetic energy is equal to gain in potential energy plus work done against friction. So work done is equal to half mv square. In place of kinetic energy, we will write this is shifted to the next side and you will write mgh. Height is 25 meter. G is given. Mass is given. Mass is 100 kg. V is given, which is 25 meter per second. And mass is given, you will find the work done. So do it. Any confusion you may ask. Now I will write for friction. Now work done is equal to, due to air resistance or friction, is equal to force of air resistance into height. If is equal to W divided by H. Put the values, you will get the answer. Now, numerical number 7. An object of mass 1000 gram is equal to 1 kilogram from a height of 30 meter is dropped from a height of 30 meter. It penetrated in the sand 4 centimeter. X is equal to 4 centimeter. So 0.04 meter. What opposing force is exerted on it by the sand? Force of opposition, we have to calculate this one. Neglect air resistance. Now, this is originally the ball was present. After this, X is equal to 4 centimeter. So we have to find the force of friction over here. So we will find the final velocity first. Here the initial velocity is 0. Here V is equal to V and we have to find. So first we will write loss in potential energy is equal to gain in kinetic energy. So half mv square is equal to mgh. Mass is given, mass will be cancelled. G height is given. We will find the velocity is equal to 2gh. So we will get this value of v square here. You can take the square root, you will get the value of v. So you will, by using this equation, you can find the value of v. Then we should find here the resistance. So here the velocity is given. Now at this point we have the velocity, we have the mass, we have the height, and we have to find the friction force. So you will write the law like this. I will erase, then I will write. Now, according to law of conservation of energy, loss in potential energy is equal to gain in kinetic energy plus work done against friction. So mgh is equal to half mv square plus f dot h. So you can find the value of f. We have the height. This is x. This is x. This is h. You will take this 31 meter, and you will take height. Height is given, and velocity we already calculated. Mass is given. G is given. You can find f is equal to mgh minus half mv square in simplified form divided by x. Okay, find the value of resistive force in the presence of resistance. Now, numerically, a body of mass m dropped from a bridge. A body of mass m dropped from a bridge into water of the river. The bridge is 10 meter high. Height of bridge is 10 meter. Find the speed of the body 5 meter above the ground. Speed is question mark at a height of 5 meter. Total height is already written. Find the speed before it strikes. V prime question mark. This is B portion, this is A. So here you will write height is 10 meter. This is x is equal to 5 meter. This height is 10 meter. So V prime here and V is here. Now first, a body of mass m drops from bridge into water of the river. So find the velocity. V is equal to 2gx. So we will write 2 multiply 9.8 multiply 5. You will get the answer. Now the second portion is consist of you will do this with now we will find V is equal to 2gh. More will be the height, more will be the velocity. 9.8 multiplied by 10, you will get the answer. You will get the answer. Now, the engine of JF Thunder Fighter develops a thrust of 3000 Newton. So force here is 3000 Newton. What horsepower does it at velocity of 600 meter? Velocity is 600 meter per second. We have to calculate power and in HP. So power is equal to F dot V. You will get the answer in watt. Divide the answer by 746. You will get the answer in HP. Now let's revise. Tomorrow we will start a new chapter. Here here they want to calculate the work done. So diagram is given in the book, which is in this shape. Distance is taken along this axis, force is taken along y-axis. This is rectangle, this is triangle. So you will find this covered area. Find the area of rectangle and triangle. It will give you, their sum will give you the work done, or Consider a trapezium. This is parallel side. By using the formula of trapezium, you can find also the area of trapezium will give you the work done during their journey, which is equal to 1 divided by 2 sum of parallel sides. You can do it in this way also, multiplied by distance between these two sides, this distance. Now here mass is 70 kg. It is written here stairs height time of flight is 4 seconds. Height is 4.5. Vertical height of the stair is 4.5 meter. This is vertical height. Power. So power is equal to work per unit time. So using the formula, work is equal to potential energy and is equal to mgh. You can find this value also. Now, here, a body of mass 2 kg is dropped from a rest position of 5 meter above the ground. What is the velocity at a height of 3 meter? So, velocity question mark. From how much height? Height is 5 meter. It is dropped from a height of 5 meter. What is the velocity at the height of 3 meter? When 3 meter height is lifted and covers a distance of 2 meter, calculate the velocity after covering a distance of 2 meter. So v is equal to 2g, x will give you the velocity. The man pulls the trolley by a force distance to a distance of 50 meter. So distance is written by applying a force of 100 Newton. Force which makes an angle of 30 degree. This is the angle. This is the angle that we have to calculate, which is given, and calculate the work done. So simple equation, right? A man whose mass is 70 kg, mass is given, walks up to the third floor of a building which is 12 meter. This is 12 meter above the ground in 20 seconds. Time is 20 seconds. Find the power in watts and HP in horsepower. So we know that 1 horsepower is equal to 746 watt. So using the formula power is equal to mgh divided by t, you can find this equation also. Now a ball of mass 100 kg is thrown vertically upward at a speed of 25 meters per second. If no energy is lost, determine the height. So you will use gain in potential energy. Gain in potential energy is equal to loss in kinetic energy. You will find mgh is equal to half mv square. You will find the velocity through this equation. Then potential energy, kinetic energy, gain in loss in kinetic energy is equal to gain in potential energy plus work done against friction. Using this equation, you will find the work done. Now work done is equal to against friction is equal to F dot H. So by using this equation, you can find F, which is equal to W divided by H. An object of mass 1000 gram falls from a height of 30 meter. So here is the height. How much? 30 meter. Height is 30 meter. Initial velocity, we have to find the final velocity here, which is equal to V. So below. First, you will find the height by using this equation. Potential energy, gain in potential energy, loss in potential energy is equal to gain in kinetic energy. By using this equation, you will find the kinetic velocity. Then by using potential energy, loss in potential energy is equal to gain in kinetic energy and work done. It penetrates this What opposing force is required to lift? By putting the value, potential energy is equal to mgh half mv square plus F dot x. You will find the value of air friction by using this equation. A body of mass m dropped from a bridge of water river 10 meter high from the water surface. Find the speed of the body 5 meter above the water. So you have to find the speed. Find the speed of the body before it strikes the water. Before it strikes the water. So you will find the heat due to this height, which is 5 meter. So you will write V is equal to 2gx. You will find the height. Find the speed of the body before it strikes. Find the speed also. E prime is equal to this. E prime by using this equation. Now last, force is how much? The engine of a J Thunder fighter develops a thrust of this one. So force is 3000 Newton. This is data. And what horsepower does it do? Does it at a velocity of 600 meter? Velocity is 600 meter per second. Power is equal to F dot V. 3000 multiplied by 600. You will get the answer in watt. Divide by 746. You will get the answer in HP. If you have any questions or any query, you can ask. Thank you, students. Allah Hafiz.